Alrighty, so we are dealing with systems of linear equations, and we're going to deal with graphing methods. So a system of linear equations consists of two or more linear equations in the same variable. A solution for a system of linear equation is an ordered pair. Remember, ordered pairs are always written as x comma y. So it's going to be x comma y that satisfies the solution. So what you need to do is when we solve a system of equations, we need to make sure that we write each equation into slope-intercept form. And don't forget that slope-intercept form is y equals mx plus b. You're going to have to get y equals mx plus b. You're going to graph each line by hand. You need to make sure that you label each line. You're going to locate the point or points of intersection. Okay? So if we take a look here, this first particular graph, we need to graph the system of equations and we need to find the solution. So you're going to be using rulers for sure. I don't in this section or not, but we'll talk about the graphing calculator, how that's helpful as well. But we need to take this first line and get it into y equals mx plus b. I'm going to subtract x on both sides. Negative y equals negative x plus 4. Divide everything by 1, and y equals 1x minus 4. So I'm going to begin this graph at negative 4 on the y-axis, and then I'm going to go up 1 to the right 1, up 1 to the right 1, and then I'm going to connect the dots. I'm going to make my lines much larger than maybe I have in the past, so they go all the way across the grid. Second equation, 4x plus y equals 1. Hold on. 4x plus y equals 1. Subtract 4x on both sides. Y equals negative 4x plus 1. This line I'm going to begin at positive 1, and I'm going to go down 4, over 1, down 4 again, over 1. I'm going to draw this line. Didn't intersect so well. I'm going to label it. And I'm going to notice that these two lines intersected, and they really intersected at that ordered pair. So my solution is the ordered pair intersection. My solution is going to be 1, 1, 2, 3, 1, negative 3. So the answer with all of this work shown is 1, negative 3. Okay, so the next one, we'll do the same thing. We'll take the first line, x plus y equals 4. Subtract x, y equals negative x plus 4. We'll graph this line by beginning at negative 4, down 1 over 1, down 1 over 1. Graph the line, and we're going to label it y equals negative x plus 4. On this second line, x plus y equals 1. Subtract x, y equals negative x plus 1. We're going to begin this line at positive 1, down 1 over 1, down 1 over 1. We're going to graph this guy, and we're going to label this guy, negative x plus 1. Well, take a look. These lines don't intersect. They're parallel. You should have known that before you graph them, because look at their slopes. Their slopes are the same. So parallel lines never intersect. So this doesn't have a solution. And that ends up being your answer. Okay, let's see what else we got. These two lines. So we've got x minus y equals 3. Subtract x from both sides. Negative y equals negative x plus 3. Divide negative 1. Y equals x minus 3. Begin at negative 3. Up 1 over 1, up 1 over 1. This guy is labeled and graphed. Take the second line, 2x minus 2y equals 6. Subtract 2x from both sides. Negative 2y equals negative 2x plus 6. Divide by negative 2. And then we get here, what? Whoa. Let's see. Okay. Let's try this again. And then we get down here, y equals x minus 3. Well, wait a second. Those are the exact same lines. So if I try to graph this one again, I'm just going to get one line on top of each other. So here's a third scenario. If I'm graphing the same line, instead of having no points of intersection, I've got all points of intersection. So you have just seen where you can have an answer that has all solutions or infinite solutions, where you could have no solution, lines are parallel, or where you've got one solution, the lines intersect. Okay, so that's what we're filling the blank in here. 3 possible solutions when solving a system of linear equations. If the lines intersect, there is one solution. And that solution is going to be, oh goodness gracious. Oh, come on. Okay, well that solution is going to be an ordered pair x comma y. If the lines are parallel, then there is no solution. If the lines coincide, if they are the same exact equation, the same line, then there are all solutions. A lot of people will say infinite solutions. Either one is fine. Okay. So sometimes your answer is not going to be an ordered pair. So with that, what's going to happen is you're going to graph the lines like you normally do, and then you're going to use your calculator to check. So we're going to graph these lines by hand first. This first line, when I subtract 4x from both sides, becomes 3y equals negative 4x plus 6. We're going to divide everything by 3. Y equals negative 4/3 x plus 2. Begin at 2, down 4, over 3, graph it, label it. Second line, just divide everything by 2, and y equals a half x plus 1. So now I'm going to begin at 1, and I'm going to go up 1 over 2, up 1 over 2, connect these dots, label its, and now my problem is that the point of intersection, which is right here, is not really on a specific order pair. So I'm going to use the calculator. So I'm going to get my calculator pulled up. I'll be right. Okay, so here we go. So what it says to do in this case is in order to find the point of intersection, you're going to have to type these equations into y equals. And then you're going to actually find the point of intersection by doing this thing right here. Second trace, intersect, enter, enter, enter. And then you're going to round near answers to the nearest hundredth if you need to. So let's get back to the calculator. The first equation we know in y equals, we're going to type negative 4/3 x, negative 4 divided by 3, x plus 2. And then we're going to go into y2 and we're going to type in negative 1 half, negative 1 divided by 2x plus 1. These two lines are going to be graphed. That's the blue line, looks pretty good. That's the red line. Doesn't look so good there. So what happened here? Let me go back for a second. It's not negative 1 half. So let's go back here. Let's delete the negative 1. It's positive 1 half. Let's graph this thing again. Let's say blue. That looks right. Red. That looks right. So that's also a good check. The point of intersection is right here. So what we need to do is we need to calculate the point of intersection. Calculate's the word that's above trace. So second trace, we want to calculate the point of intersection. We're going to hit enter once where it talks about do we have this first curve or the y1, and that is correct, so we hit enter again. Do we have the second curve, which is our second line, y2? Hit enter again, and it says, well, should I guess your point of intersection? And we definitely want that to happen. So there's our point of intersection. It's over about a half and up about 1.3. And that kind of looks, I guess, a little bit right, but we're not as accurate as we could be just because of drawing by hand is not great. So what ends up happening here is nearest hundredth is going to be 0.56, 0.55, and 1.27. So 0.55 and 1.27 right here. So 0.55 and 1.27. That's going to be our solution right here. Okay, let me just double check that I did that correctly. So 0.55 0.55 and 1.27. Perfect. Okay, so that's your solution. Let's see what else we got. That's it. The rest of it's homework. Okay, so you should be good to go for the homework. Good luck.